we're going to look at this function here and try and determine its inverse function. Okay, so the function we have here is fx equals to x minus 1 all squared minus 1. Okay, now in part A, the first thing I'm going to do is try and sketch this function. Okay, so let's sketch fx. So because we have a squared there, it looks like it's going to be some sort of parabola. Okay, so hopefully we already know how to draw this. It's going to look like this. Okay, so it's going to be shifted 1 unit to the right, and it's going to be shifted 1 unit down. Okay, so 1 unit to the right and 1 unit down. So that's my parabola, that's my function there. Now in part B, it's going to ask me to find the largest positive domain of fx, this one, so that my inverse function exists. Okay, so right now, it currently does not exist because, my inverse function that is, does not exist because this is not a one-to-one function. Right now it's a many-to-one function. Okay, that's why it's asking me to find the largest positive domain. Okay, so we're trying to restrict the domain in order for this to be a one-to-one function so that an inverse exists. Okay, so how are we going to find the largest possible domain? Well, for this function to be one-to-one, what we're going to do is we're going to take kind of a half of the graph. Okay, so if I just cut it in the middle and I restrict the domain just to this part, okay, then this is one-to-one. And similarly, the other half. If I discard this half and only take this part, then this portion of the graph is one-to-one. Okay, but specifically it's asking me to find the largest positive domain. Okay, so the positive domain, I want to take x is greater than 1. Okay, so instead of the bottom half, which is a bit of using my negative domain, I'm going to take my positive domain, so this part. So just taking that domain or that part of the graph will have a one-to-one function, meaning my inverse will exist. Okay, so that's my domain. Now in part C, it asks me to fully define my inverse function. Okay, so I want to, at the end of the day, I want an equation for f inverse x. Okay, that's what I want. Okay, so in part B, we found that for me to have an inverse function, my domain of my original function should be x is greater than or equal to 1. Okay, so if I want to sketch the inverse of it, or find out the inverse of that, the domain of my original graph, or my original function, should be the range of my inverse function. Okay, so the domain, x is greater than equal to 1, should be my inverse, sorry, should be the range of my inverse. Okay, so that will be y is greater or equal to 1. Okay, now what I'm going to do is try and define inverse of my inverse function. Okay, so in order to do that, I want you to take a look at this. So an inverse function is interchanging my x and y's. Okay, so I'm going to switch them around. So I'm going to take this equation and I'm going to put an x into my fx, and everywhere where it has an x, I'm just going to put a y. Okay, and that's what I drew here, or that's what I wrote here. Okay, so instead of x minus 1 all squared, I have y minus 1 all squared minus 1, and that is equal to x. Okay, instead of fx. Okay, from here, to find my inverse function, pretty much I want to find or make y the subject. Okay, then that will give me the equation of my inverse function. Okay, so let's try and do that. We're going to make y the subject. So first of all, let's move the basic stuff. So I'm going to move the negative 1 to the other side. So that's x plus 1. Okay, from there, again, I want to make y the subject. So in order to get rid of the square, I need to square root it. Okay, so if we square root both sides, don't forget we have a plus minus. Okay, there's no reason to not consider that. And also, if we move my 1 to the other side, then this is what we get. Okay, now from here, we're going to kind of take into consideration the fact that my range is y is greater than 1, or equal to 1. Okay, this is significant because we got this range from the domain of my original function, okay, which is very important for us to have an inverse. Okay, so we have to deeply consider my range that y is greater or equal to 1. Okay, well, why? Now in this here, we've got a plus minus root, okay, x plus 1. Okay, from here, I am going to just discard the negative. Okay, now the reason why I do that is because if I have a negative in there, then my range will not always be y is greater than or equal to 1. Okay, so for example, if my x was, say, a number like 5 or something, and I have negative root 5 plus 1, I will get some negative number. Okay, so I don't want that. I want my range to be y is greater than or equal to 1. Okay, so that's why we just discard the negative and keep the positive. Okay, so y is equal to that. So this is my equation of my inverse function. So to fully answer the question, I want to rewrite like this. So f inverse x is equal to that equation. So square root x plus 1 and plus 1. Okay, so that's how we answer this question.